In this video, we're going to go over osmosis. These are the key points for osmosis. We're going to go through the practice questions. So, plant cells are placed in an isotonic solution. So remember, my annotation for isotonic is I draw a cell and water is moving out and in evenly, and that doesn't change. All right, it says additional amounts of salts. Salts are simply solutes, so remember that's what's being dissolved. So that would be like the Kool-Aid from our example. So they're quickly added to the solution. So solution is solute plus solvent, but solution is simply outside the cell. All right, so I'm going to draw this. So it says additional amounts of salts or solute, so I'm going to represent my salts with little dots to represent my little molecules. So if I'm adding solute, right, so I'm adding solute outside or into my solution, I know that water always travels toward solute, so my direction of water is going out. You can ignore this answer choice. Cross it out. Okay. I know that water flows toward my solute, so now I see that water is leaving my cell. If water is leaving my cell, then my cell is going to shrink. All right, so I'm looking for an answer that matches. So I know that shrivel means get smaller. Rupture means explode. And staying the same just means it's still in an isotonic solution. So the cell is not staying the same. That's not an answer choice. The cells will rupture or explode. That's not happening. That's the opposite of shrink. But the cells will shrivel. Well, yes. That's another way of saying that the cell shrinks. All right, number 2. A plant cell is placed in a hypertonic solution. So if I see hypertonic, I'm going to draw my annotation. That means that the cells are getting smaller. What will happen to the plant cell? So this means cells are getting smaller. So I'm going to look for something similar. Cells will shrink. Shrink means to get smaller. So that will most likely be my answer choice. Burst means explode or rupture. The cells will rupture means also explode. So neither of those are happening. Cells will stay the same. That's isotonic. So I know, based on my process of elimination, that this cell is going to shrink. A is my answer choice. Flip your page. All right, the plant cells below were placed in a hypotonic solution. So the first thing I'm going to do is draw my annotation. My cell is going to swell. Cell is going to swell. So I'm looking for an answer choice that matches that the cell is going to swell. Osmosis, when it's inhibited, this just means stopped in the cell. So if it's placed in a hypotonic solution, that means that water is flowing in a certain direction. So osmosis is happening. So this is not true. It's not a match. The pressure from osmosis caused the cell to burst. So I know that if the cell gets too much water in it, it's going to burst. Just like if you fill a balloon with too much air, that is going to burst. So this is a contender right now. Osmosis caused the cell to shrink. Well, no, that's the opposite. And the cell was damaged by a virus. Well, there's no info about that. So that's not a match. I'm left with my answer of B. All right. Number 4. So this is A, B, and C. So it says study the drawings of the 3 solutions. Identify the 3 types of solutions. So I see in A, water is flowing out and in evenly. So this is going to be isotonic. I could also draw my annotation of drawing out and in. Water going out and in evenly. Here, I see that water is entering my cell. If water is entering my cell, then that means that it's hypotonic. You could also draw a little cell becoming a bigger one because it's swelling with water. And then finally, I see that water here is leaving my cell. And my cell looks smaller, so this means that it is in a hypertonic solution. Hypertonic, again, is a cell getting smaller. So if on the test you're annotating the diagrams, you could write the word or you could draw the annotation or both. All right, number 4 answer choices. I know that my first picture is going to be isotonic. A is going to be isotonic, so I can right away eliminate A and B because they start with hypotonic. So now I'm left between C and D. So I know A isotonic, B hypotonic, C hypertonic. This matches. If I look at D just in case, it says that B is a hypertonic solution. That's not true. All right. Why does spraying fruits with water help them look better or fresher? Well, I know a fruit is a plant. And the part of the plant that fills with water is a vacuole. I know that vacuoles hold water in plants. All right, so I'm going to look for something to do with vacuoles. So plant cells with a hypertonic solution gain water. Well, first of all, this is just false. If it's hypertonic, then it's losing water. Plants do not have a cell wall. That is also false. Plants do indeed have a cell wall. Water cannot move the selectively permeable membrane. Well, water does move through the selectively permeable membrane. That's how osmosis happens. So this is also false. All right, now I see something with vacuoles. Vacuoles fill with water. Yes, this matches. Not only does it match, even if you didn't know the answer, all 3 of these statements are false. They don't make any sense, so you could pick it based on a process of elimination. And that is our review of osmosis. Go to the next video if you want a review of types of transport.